Hi, this is lesson 12.3. We're going to look at geometric sequences and series. A geometric sequence is a specific type of sequence, one where we are multiplying the same thing every time. The mathematical definition here is going to say that a sequence is anything with a common ratio, and that ratio is just that thing that we're multiplying together. We call that thing r, and we will use that variable throughout most of this lesson, where we're looking at what does that multiply by. It can be positive, negative, can be really big, can be a fraction, so anything like that. We'll look at the first example of a geometric sequence here, and it's basically as simple as just looking and checking, does it multiply by the same exact thing every time? And so it looks like in this situation, because we go from a negative to a positive, it's safe to assume that we're going to have a negative r value. It's multiplied by negative 4 there, negative 4 again here, negative 4, negative 4. So it appears that our common ratio is in fact negative 4. And you'll see that alternating when we have positives and negatives. That's kind of how we will use the r values. Here is the general rule for a geometric sequence. It's easier than arithmetic because you don't really have anything to simplify. There's two parts that make up the rule. You've got to put the first term in, and then you have to have the r and then to the n minus 1. And remember that the n minus 1 is there because that first term we don't really multiply by r. So we have to have the first term kind of by itself, and then it's after the first term finally you start multiplying by r. So here's an example of just a pattern here. We've got 972 as the first term. It alternates to a negative 324, then 108, and then down to a negative 36. So a couple of things here. We notice that it's going to alternate from positive to negative, so our value is probably going to be negative. We also can see that the numbers are getting smaller. All right, they're approaching 0, and so our value is probably going to be a fraction or something less than, well, between 0 and negative 1 in this situation. All right, so how do we figure out the r value? Well, it's as simple as saying, okay, well, what multiplies 972 times something should give us negative 324. And if we divide both sides by 972, you'll get your r value. Well, it really, you can do that for any term. Take one term, divide by the previous term. So you could figure out r by taking negative 36 divided by 108. And it's really up to you. You just take any term, divide it by the previous term. Try to keep it as a fraction. It's a little bit more accurate, especially in this situation where it does go forever. R is a negative 1/3. We'll start plugging that into our formula then. A sub n is equal to a sub 1 is our first term. That's 972. So I'll put that 972. We need to keep a sub 1 and r separate somehow, so I like to use a parenthesis. I always know that my r value will be in the parenthesis. Same kind of goes for how you type it into your calculator. You want to probably put a parenthesis around that. And so there's a sub n. We can get any term. This is an explicit rule. We can get any term given the n value. So if you want the 100th term, plug 100 in. I'm going to have you try this example on your own. So you'll find this checkpoint in the quiz after the video. All right, so let's try something a little bit more difficult. Obviously, that one pretty easy when you're given both r or given enough information to find r pretty easily. What do we do if we are given two kind of random points? You've got a sub 2, which is 10, and you've got a sub 7, which is negative 320. So before we go dive into this, we can do a little bit of pre-thinking here. I noticed that we start with a positive 10, and eventually it gets to a negative 320. Only a negative r value would do that. So we've got that. It's getting bigger, so r is going to be a bigger number, like, well, greater than 1, and then it's going to be negative, so kind of less than 1. And much like we did with the arithmetic, we're just going to look at how do we get to the next point. And then we're going to kind of continue that pattern until we get to a sub 7. Well, a sub 3 would just be 10 times r, because we're just multiplying by a common ratio. This next term would be 10 times r, which would be 10r squared. The next term after that would be 10r to the third, 10r to the fourth, and then finally this term would be 10r to the fifth. And of course, the easier way to look at that would simply just to say, well, take 7 minus 2. There's 5 terms. 5 things need to happen before you get to a sub 7. So we automatically know that if I take that term, 10, if I multiply it by r 5 times, which is times r to the fifth, I should end up with negative 320. All right, well now we have to solve for r. So I'll divide both sides by r, or I'm sorry, by 10. You can use a fifth root in your calculator, but I find the easiest way to do this is to raise the exponent to the 1/5. Those two things will cancel out, and r is negative 2. All right, we have our r value. We now also need our a sub 1. Now in this situation, we do have a way to find a sub 1 because a sub 1 is just 1 back from a sub 2. So all we need to do is the opposite. So if we're multiplying by 2 when we go to the right, I need to divide by 2. In fact, negative 2. I need to divide by negative 2 to go back. And so we would find out that a sub 1 is negative 5. And we could use that. But I don't want to rely on that method because what if I gave you a sub 90 and a sub 98? All right, you need to be able to solve for that a sub 1 without it. So the idea is that we can just go back to our general rule. If I know that a sub 2 is equal to 10, that means n is 2, I would get a 10 here, a sub 1 r to the 2 minus 1. And now I know r is negative 2, so I can plug in a sub 1 times negative 2. 2 minus 1 is just 1, so that's just going to go away. And so you can see how you're going to be able to divide, and we get our negative 5. So I don't want you to have to rely on that, but it's easy problem solving, and you just want to use the simplest method that you can. So a sub n now is our final answer. I'll start with our a sub 1, and we've got our r value to the n minus 1. This next checkpoint you are going to try on your own. Here's a sub 3 and a sub 6. Again, not anything too crazy, but using that same idea. We're now going to look at how we sum these series. And this is, again, for a finite geometric series. You'll recognize down here summation notation. We are summing from the first term up to the 13th term. And here is our rule. 3 times 4 to the I minus 1. So how do we find the sum of this? Well, we look to the sum rule. It's a complicated looking rule, but it really isn't too bad. You're going to sum by taking the first term, and then you're going to multiply. In the numerator, it's 1 minus r to the n. This is probably the most difficult thing, and this is where you need to take special care typing into your calculator. In the denominator, it's just 1 minus r. I often like to rewrite this. It's a little bit easier to do by moving that denominator. I mean, remember, a sub 1 divided by 1, you could move, you're just multiplying, so you can move that denominator. This is the tricky part in a calculator. The 1 minus r to the n can be tricky. So we just want to make sure that we type this in carefully and follow the pattern. So if I'm trying to find the sum of this series down here, again, we're going from 1 up to 13. We're going to find the sum of the first 13 terms. A sub 1 is 3. I can tell that by looking at the rule, but you could also just plug 1 in. All right, since you could put a 1 in for I right there. 1 minus 1, that's going to be 0. 4 to the 0 is 0, and so we're just left with 3. I'm going to use the second rule here. It's 1 minus r, so my r value, what is it increasing by? It's multiplying by 4. And then we're multiplying 1 times 4 to the n. And n again is how many terms are you summing up, and we're summing up 13 terms. Most of the time, this fraction you can complete on your own. So it's 3 divided by, well, 1 minus 4, that's just negative 3. So it's 3 divided by negative 3, it's just negative 1. And then you got to take 1 minus 4 to the 13th. And you'll need a calculator for this. But that is much easier to type in now, so you just put the negative 1 out front, and you take 1 minus 4 to the 13th. And we get a total sum of, well, it's a really big number. 67 million. All right, we can check our answer. I mean, does this answer make sense? Should we be getting a really big number? And I think it does. We're going to be multiplying by 4. That's going to grow very rapidly. Use the rule to find the sum of the first 11 terms in the quiz here. This last question I'm going to leave you with to see if you can figure out some of this on your own. A pendulum is released back and forth. So here's a pendulum. And it is swinging back and forth. On the first swing, it travels 120 centimeters. When it goes back, it does not travel as far. It travels 97% of the distance. So we're multiplying by 0.97 to find the length of that swing was 116.4. Then it swings backwards. It doesn't swing quite as long because, again, you multiply by 0.97. And so on and so on. The pattern continues. I want you to try and find the first 12 swings. We will continue this idea, this lesson, on 12.4.